Great, and congrats for completing the questions from .NET Framework topic. Now we have a new and very important topic for .NET interviews, and that is SQL. We will start from the very basic question, and here is the list of 8 questions. Here we will cover questions on DBMS, RDBMS, constraints, primary key, unique key, trigger, views, having, where, all basic things, okay? As a developer, we must know all these things in SQL. Even if you already know the answers of these questions, even then I recommend you to at least go through them at least once. The approximate duration of all these questions is just around 15 minutes. What is the difference between DBMS and RDBMS? This is a very basic question, and if we see the diagram here, DBMS store data as files. For example, here we are storing data in XML files. Different data is stored in different files, and there is no relationship maintained between these files, okay? But as you can see, in case of RDBMS, data is stored in tabular format, okay? Relationship is also maintained between the tables. Now let's check out the differences one by one. First is DBMS stores data as files, okay? RDBMS stores data in tabular format. Second difference is in DBMS there is no relationship between data, but in RDBMS data is stored in the form of tables which can be related to each other. Example with foreign key relationship. Third difference is in DBMS normalization is not present, but in RDBMS normalization is present. Then DBMS deals with a small quantity of data, okay? It's not good to put big data in normal DBMS, but RDBMS deals with a large amount of data. Then next difference is DBMS example is XML. Yes, you can save the data in XML files. And RDBMS example is MySQL, SQL Server, Oracle, Microsoft Access. So basically, mostly we work with RDBMS only. All these are the relational database management systems. Got it? What is a constraint in SQL? What are the types of constraints? Okay, this is an important question. In simple English, SQL constraints are used to specify the rules of the data in a table. In other words, constraints are used to limit the type of data that can go inside the table. For example, if you will try to enter a null value in a not null column, then it will not allow and give an error because not null is a rule. It's a constraint for that column, right? Now let's see the types of constraints. See here we are creating a students table and applying all the types of constraints in it, okay? First is this primary key constraint. Primary key is a field which can uniquely identify each row in a table. That means duplication values in single column are not allowed in primary key. It's like the ID, the identification of the row. Primary key will also create clustered index on that column also, right? Second is not null constraint. Not null constraint tells that we cannot store a null value in this column. Third is foreign key constraint. Foreign key is a field which can uniquely identify each row in another table. Basically, it is needed to set relationship between the two tables. For example, here column course ID is just the ID of the course in this table. But all the details of that course against this course ID are originally present in this courses table. Okay, so this is the relationship between this courses and this table. The next constraint is check constraint. Check constraint helps to validate the values of a column to meet a particular condition. For example, in this case, you cannot insert the age which is less than 18, right? The age must be greater than 18, and that is the check. This is the rule of the check constraint. Next is default constraint, which is specify a default value for the column when no value is specified by the user. So it's like if you will insert a row in this table without the admission date, then it will automatically save the admission date by using this default get date method. Okay, but if you will provide some admission date value while inserting the row, then it will ignore the default value. And the last one is unique constraint. Unique constraint tells that all the values in the column must be unique. There should be no value, no two values, duplicate values are not allowed. Now, it is a bit similar to primary key, but the differences we will cover in upcoming questions. All right, now you know what are the types of constraints. What is the difference between primary key and unique key? All right, simple question, but asked in many interviews. First thing is primary key cannot accept null values, okay? Whereas unique key can accept only and only one null value. Remember, only one null value is allowed in unique key column. Second difference is when you create a primary key, it will automatically create the clustered index for the column. Whereas unique key will not create a clustered, but the non-clustered index automatically for the column. Then the third difference is only one primary key can be present in a table, not more than that. But more than one unique key can be present in a table. I hope these differences are easy to remember for you. What are triggers and the types of triggers? Let's see the definition first. Triggers are stored programs which are automatically executed or fired when some event like insert, delete, or update will occur. So suppose you have, let me explain this with example. Suppose you have a table locations. Now, whenever some data will be inserted or deleted or updated in locations table, then you want to keep the track of it. Okay, you want to track it, and therefore you created this location history table to record the update. So to record data in location history table, you will create a trigger like this. So trigger is used for tracking the delete. So if suppose you want to delete something from location, so you have to track that, okay, when the data is deleted, at what time it is deleted. So that kind of information can be put in the location history table. Now, see this trigger, this tree update location is, this is the trigger name. Then location is the table name on which the trigger is created. Okay, meaning if any update query will be fired on this locations table, then this trigger will be fired. And what trigger will do? It will perform the logic present inside this trigger body. In this case, we will just inserting a new record in location history table. So that is the trigger. Mostly we use triggers for tracking the changes happening in our database table. Now next part is how many types of triggers are there. This is the chart of types of triggers. Remember, this DML, DDL, and logon are the categories of triggers, but the actual types are instead of triggers and after triggers, etc. Like this one. I will only explain DML triggers, category triggers, because this DDL and logon triggers are mostly used by DBAs, and we already like saw here the after trigger. Now in after trigger, update on the table executed first, and then after trigger will be fired. That is why its name is also after trigger. Now let's see the second DML trigger, which is instead of trigger. Instead of trigger are slightly different. First of all, you will use instead of a statement like this. So in the example, if anyone will try to insert data in this view employee details, then this instead of trigger will stop or forbid this insert execution. Okay, and instead it will execute some other command which can be written inside the logic here. For example, suppose there is a view which is just for read only purpose, but now someone is trying to execute any insert query on that view. Then this trigger will not allow the insert query and will record this activity somewhere else for security purpose, right? So like in short, this instead of trigger will help in security also. So at last, the definition is an instead of trigger is a trigger that allows you to skip and insert, delete, or update a statement to a table or view and execute other statements defined in the trigger instead. Okay, I hope now you have a good understanding of triggers. What is a view? Let's try to understand with the help of a diagram. See, here we are joining two tables, A and B, with the help of a query and finally creating a new view like this. Remember, in case of view, only query is stored, but the actual data is never stored in memories like a table. Okay, so the definition of view we will look, it's a view is a virtual table, virtual table which consists of a subset of data contained in a single table or more than one table. So single table means view also can be created like by writing a query where only few columns are selected. This is how, okay, so for example, if you have a table and you want to create a view, only 3 columns in it, so you can create that with the single table. Now this is how we can create a view on the customers table. The view India customers will only contain customers whose country is equal to India. Now the question is, views are not stored in memory like tables, then why do you use views? What are the advantages of views? First advantage is like table views can be indexed, okay, and indexed views can improve the performance in reading the data, right? Indexing improves the reading of the data, right? It will increase the speed. Second reason is extra security. Now what happened? DBA can hide the actual database and table names and expose views for read operations only. Take for example, suppose there is a table which data is very confidential, okay, and therefore DBA do not want to share even the table name with the developers. Now what he will do? For that, DBA will create a view on that table and then he will give that view name to the developer, and developer can write a query to read the data from the view. Okay, developer still don't know that actual table name. In that way, table name remains confidential and secured. That is one of the purpose of the view. Okay, great. So now you know enough details about the views. Again, a very important question. So let's try to understand with the help of queries. Let's look at this query which having both where and having clause. Now see this query carefully. You will notice the first difference. Where clause is used before group by clause, okay, and having clause is used after group by clause, right? That is the first difference. Now see the next query. Now we know where clause cannot contain aggregate function, but if you see this query, then you will find that having clause can contain aggregate function like this. These are the differences between the where and the having clause. Now simple thing is normally we use where clause with the select statements, but with group by we prefer having statements. What is subquery or nested query or inner query in SQL? First of all these three are same things. See this query carefully. This is the outer query, and here inside this an inner query is embedded in where clause. That's it. Now this where condition is dependent on the results of the office code this query will give. Okay, this query will give some result and like some set of numbers, and then where condition will check that whether that condition will match. Okay, so basically the definition is a subquery, inner query, nested query is a query within another SQL outer query and embedded within the where clause. Simple and sweet. What is auto increment and identity column in SQL Server? This is a very basic question. Let's see the example first. See here we are making this ID as the identity column of the employee table. So you need not to insert any value in this ID column. It will automatically start from the value 1. And if you have inserted 5 rows in the employee table, then every time you insert a new row like this, then the new value of ID will be incremented by 1 from the previous value. So like this, 1, 2, 3, 4, and so on, it will be incremented. So the definition is auto increment allows a unique number to be generated automatically whenever a new record is inserted into a table. And mostly auto incremented is set on the primary key only. Okay, remember setting this 1 comma value for identity column is up to you. From what value you want to start and how much you want to increment on the previous value, that is up to you only. Now you know, since this identity column are always unique and not null, therefore mostly we mark them as primary key. All right, after completing the basic questions in SQL, in this section we will cover the questions on joins and indexes. The most asked question in SQL are from this topic only. Here is the list of 8 questions. First we will cover questions on types of join, self-join, and then question on indexes, clustered, non-clustered, differences between them, and how to use them. The approximate duration of all these questions is just around 13 minutes. What are joins in SQL? This is a very basic question, and my funda is always to start from the basics only. So see, here we have two tables, table A and table B. Okay. Now suppose we want to get a result set with student ID, name, and department column all together. For that, we will use join. We will join these two tables like this, and finally we will get the desired result like this. So the definition is a join clause is used to combine rows from two or more tables based on the related column between them. Now here is the example. Student ID was here in this example. Student ID was the related column. Now you are ready with the basics. Let's go to next question. What are the types of joins in SQL Server? This is a very, very important question and almost asked in all interviews for basic interviews. Okay. So first of all, outer join, we have three types of outer join. First one is left outer join. A left join returns all the rows from the left table and along with the matching rows from the right table. See in the diagram here, all the rows from the left table A will be there, right? But yes, the columns you can choose from both and A and B table. You can list this in the select column names list. Okay. Next is right join. A right join returns all the rows from the right table along with any matching rows from the left table, just opposite to the left outer join only. The third one is full outer join. A full outer join returns all the rows from both the left and right tables in the join. That's it. Then these are the three types of outer join. Now the most important and the most used one is, yes, it is inner join. An inner join returns only the common rows from both the tables and that meet the join condition. You can also see this query for this inner join and all these joins. It is pretty simple and straightforward. Based on your requirement, what kind of result, the final result you want, you can use the types of join in your queries. What is self join? The definition is very simple. A self join is a join of a table to itself. But this use of self join is slightly confusing, which I will explain now. Normally we join two tables, right? But in self join we join one table to itself only. The main thing is, what is the purpose of this? Why we are joining the table to itself? Now let's see what does it mean and when to use it. Suppose you have an employee table like this. Here all the employees with their employee ID are present, right? Managers are also employees, so they are also present in this table with their employee ID also, right? Now most of the employee will have a manager, right? Therefore in the same table there is a manager ID column. Now listen carefully. In this manager ID column, we will put the employee ID of the manager of that employee. Getting my point? For example, my name is Happy and my employee ID is 100. And my manager name is John and his employee ID is 200. So both these records are present in this table. And in my record, where the employee ID is 100, corresponding to that, the manager ID will be 200, who is John, who is my manager, right? So there are no separate tables for managers. All is in the same table employees. Now suppose your task is to write a query to get all the employees' name with their manager's name. For example, you want like a Happy, my name, and my manager John. So Happy and John. You want these two names for so for that we will use what? Yes, self join. So suppose this is the output you need, employee name with manager names, all the. So this will be solved. This will be the query we will use. And see here we are left joining employees table with the employees table only. And this is possible with the help of using these different aliases E and M. And the condition will be like m.employee ID equal to e.manager ID. Because yes, manager ID is the column we have, right? And order by manager is just optional. Now this result we will get all employees with their manager names. You might say there is no manager name column here. Then how you get it? Basically, while self joining, we will consider the first table as the employee, which is basically E, and the second table we will consider it as manager's table. It is employee with M alias, which is like it will be considered as manager's table because managers are also there present in the employees table, right? So it is like this, and above this m dot first name means the manager first name, and I think now you know the use case of self join, right? In short, sometimes we do not have multiple tables, and at that time we have to join the one table with itself only to get the desired results. That is self join. Are indexes in SQL Server. As always, let's start with the example. Now, suppose you have a table T1 with huge data. Okay, huge. Now, if you will write a search select query with the where condition in this table, then the result will be very slow, right? Like because now suppose if you have to index on this one primary key column and store it in separate place like this, then it is easy to search in this one column, right? And that is the benefit of indexing. The first point you have to remember is SQL indexes are used in relational databases to retrieve data very fast, or we can say to improve the performance of the queries. Now they are very similar to the indexes at the start of the books. Okay, which purpose is to find a topic quickly. See, we have indexes in book, then how easy it is for us to search the topic, right? Otherwise it will be very difficult. This is the brief idea about the indexes. What is clustered index? Let me give you an example first. See, this is a dictionary. Here B is the index, and below that we have all the data of related to B here, right? So basically B, which is the index, is physically stored along with the data only, right? Similarly, a clustered index is an index which defines the physical order in which table records are stored in the database. Also in dictionary, you can have items in alphabetical order, right? No other way. So only one index is possible in the dictionary, right? One way, right? Similarly, table data can be stored in only one way. Therefore, there can be only one clustered index per table is possible. Now, next point is in SQL Server, if you set a primary key on a column, then it will automatically create the clustered index and on that particular column, right? So this is like the high level, or I say the brief details about the clustered index. What is non-clustered index? Again, let's see the example first. See, this is a book index which is at the starting of the book, right? But it is not present along with the data, the content. This book index is stored separately from the data, not like the dictionary where the index was also present along with the data. Similarly, a non-clustered index is stored at one place and table data is stored in another place. So this non-clustered index is not physically stored with the data. Like in the case of clustered index, it was physically stored with the data, right? Another important point is a table can have multiple non-clustered index in a table. Like in a book, you can have multiple type of indexes, right? Some books can have this alphabets wise indexes like this also, which mostly are there at the end of the book, right? End of the book, you can find multiple indexes, right? Here also page numbers are mapped. This is the brief idea about the non-clustered index. What is the difference between clustered and non-clustered indexes? This is the main question asked in the interviews, but I already explained clustered and non-clustered index separately, so this is going to be very easy for you. Let's quickly see the differences. First is, a clustered index is a type of index that determines the physical order of the data in the table. It is a bit similar to dictionary, which index is physically stored with the data itself. Then a non-clustered index is stored at one place and the table of the data is stored in another place. Bit similar to the like book indexes, which are stored separately from the data or the content of the book, right? Second difference is, a table can have only one clustered index, but a table can have multiple non-clustered index. Then the third difference is, clustered index is faster. Like in dictionary, the search is so fast, right? Directly go to the alphabet from which the word is started, so fast. But non-clustered index is slightly slower. Like in a book index, you have to open the index first, then you have to find the topic page number, and then you will go to the actual page number. It is good, but yes, it is slow as comparison to the dictionary or the clustered index. Now remember one thing, while creating multiple non-clustered index for in a table, do not create it for multiple columns. Like create it, but wherever it is required. Otherwise, a non-clustered index is stored separately, right? And if you will create multiple non-clustered index, then they are also taking some memory, some space. So, and if it is not required, then it's not good. That are the differences between clustered and non-clustered indexes. How to create clustered and non-clustered index in a table? Yes, you can create clustered index on a table like this. Create clustered index, index name, and on table name, and then in bracket you can write the column names. And then this is the query to create the non-clustered index. Create non-clustered index, same like the clustered index only, index name, on table name, and then in bracket you can write the column names. Now normally when you create a primary key constraint, a clustered index on the column is automatically created, right? But if you do not want a primary key in your table, or if you want, like, you drop the clustered index from the primary key, and then you can also create a new clustered index with some new column. So this is the way, this is the query you can create the clustered index in this, right? It's short and simple. In which column you will apply the indexing to optimize the query? Select id comma class from student where name equal to happy. So this is the query, and you have to improve the performance. So this is a tricky question, and if you have ever created any index, then you know it. But if not, then also not a problem. Then now you will know it. Okay. So this is the query we have. Normally by default, clustered index is on primary key column. So here we are talking about the creating the one non-clustered index. Okay, because we do not create clustered index, it's by default on primary key. Now the answer is, we should create non-clustered index on the columns which are after the where condition, and in this case, this name is after the where condition. Do not create non index before the, like, for the select columns. These columns do not create for them, because your query execution, the time taken by your query execution, whether it will be fast or slow, it is dependent on this where condition column, not the select columns. Okay, now you know for what column you will create non-clustered index in your table. The columns which are frequently used in the where conditions, right? All right, we covered the SQL part. Now we will cover PL/SQL part. PL stands for procedural language, and it deals mostly with stored procedures and functions. If you see the list of these 9 questions, we will start from the importance of like SQL interviews, that you must know differences between procedure and functions. Very important question. And then we will see CTE and the remaining questions. With this, you will be covering almost 100% of SQL interview questions. The approximate duration of all these questions is just around 19 minutes. What is the difference between stored procedures and functions? At least three. Undoubtedly, this is the most important questions in SQL. Make sure that you can remember at least three differences. So let's start. See, this is a basic and simple stored procedure here, which is having one in parameter and one output parameter. Okay. Then inside we are inserting the data in the table employee. And down here is a basic function. See, it has only input parameter and always returning some value here. Now let's see the differences between them one by one. First difference is SP may or may not return a value, but functions must return a value. See, function always return value, but SP can be used to insert, update, or delete data also. It may or may not return. Second difference is SP can have input output parameters both, but function only have input parameters. See, there is output parameter in stored procedure, but no output parameter in function. Next difference is we can call functions inside a SP, but we cannot call SP from a function. Sometimes inside a SP you may need to call a function. For example, I have created a function to split a string based on comma. Okay, so one string I will get, and based on the comma I will split that. For that I will create a function. Now function will return the list of the values, like splitted values. That function I can call in many stored procedures. So basically it's like the reusability, but yes, inside the function you cannot call that stored procedure. Okay. Next difference is we cannot embed or use SP in SQL statements like select, insert, update, delete, merge, etc. But yes, we can embed or use them in functions like this. For example, here select star comma dbo.fn country. Here in this SQL statement, fn country is a function here, okay, which is the advantage of function. But like it can be used with the queries also like this. But we cannot write select like this with the stored procedures. Another difference is we can use try catch exception handling inside SPs, but we cannot use try catch inside the functions. Then one last difference is we can use transactions inside SPs, but we cannot use transactions inside the function. So that's it. That's our, I think, the enough differences. Please make sure to remember at least three of them, whichever three I think whichever you think is clear to you. Okay. How to optimize a stored procedures or SQL query? This is a performance related question. Many things you can do say here, but I will point 6 very important things which you can do to improve the performance of a stored procedure. Okay. So first is when you run an insert or update query in SQL Server, then you have seen multiple messages like this, one refactored multiple times, right? So basically inside a SP, there is no need of these messages, right? And these messages displaying is basically impacting the performance slightly. So to avoid these messages, use set no count on at the top of the stored procedure. This will then not write these messages, and therefore it will save some memory. Second thing we can do is specify column names instead of using asterisk in select statements. See the incorrect way and the correct way below it. Make it a practice. If you need all the columns, write all the columns. But rarely you will need all the columns, right? So basically you have to write the names of the columns and avoid this asterisk sign. The next thing for performance improvement is use schema name before the object or the table names. See here I used DBO, which is the schema name. If you have multiple databases, then use the database name instead of DBO. Okay, that will improve performance. Otherwise, first the query will try to find the right database, which is again like performance heavy, right? Next thing we can do to improve performance is with if conditions, use exists instead of count, like shown here. Okay. Then use transactions when required only. Okay. Do not overuse it in your SPs. Transactions are secure, but they are performance heavy. So if not required, then do not use them. Then the last point to improve the performance is do not use dynamic queries. Like it's like from the security perspective. Okay. Dynamic queries are vulnerable to SQL injections. So avoid to use dynamic queries in your stored procedures. Now there are many more things for performance, but I'm keeping it short and crisp and so that it is easy to remember. What is a cursor? Why to avoid them? Let's first understand the cursor working quickly. Okay, it's a 5-step process. First, declare the cursor with the cursor name and the select query for which cursor will iterate. Now, if you see the definition of the cursor, a database cursor is a control which enable traversal iteration over the rows or the records in the table. So this is the table or select statement in this example over which cursor will iterate. Okay, so this will justify the definition. Second step is open the cursor like this. Third step, fetch each row record from the cursor using the while loop, and with each row or iteration you can do any kind of operation here. Like here I'm printing product name and list price with each iteration. Okay, that is the main purpose of cursor, fetching each row and perform some logic then inside each row. After that task is done, next step is to close the cursor because its work is over, and the last step is to deallocate the cursor from the memory. Now steps are not generally asked, but it's good to know them, right? These are the 5 steps mentioned here. Maybe later you need it for revision. The next part of the question is why we should avoid the use of the cursor. What are the limitations of the cursor? The answer is a cursor is a memory resident set of pointers, meaning it occupies lots of memory from your system, which is basically not good for the performance. So if possible, avoid the use of cursor. But if some logic is not possible otherwise without cursor, then yes, you can use cursors there. Now great. Now I think you know the role of cursors now. What is the difference between scope underscore identity and double at the rate identity? Now, before the differences, let's see the similarity first. Both these are used to get the last value generated in the identity column of the table. Okay, we have the identity column most of the time. It is primary key, right? So these both scope identity and identity, like you can use these inside some stored procedure to get the identity which has been increased. Okay, so Now the difference is double @identity function returns the last identity value generated within the current session, regardless of the scope. Now here session means this will return a value generated by an insert statement like a trigger, stored procedure, or batch of TSQL statements. See the way, this is the way we get the last identity from this select identity. Okay. Now the problem with identity is if insert query will be performed by trigger and stored procedure at the same time, then this select identity can give different results. Okay. So this is not the so reliable way to use. Okay. The more reliable is scope underscore identity. The scope underscore identity function returns the last identity generated in the same session and the same scope. Now in this SP trigger batch, all the last value generated will be in sync. Okay, so whether you are inserting from stored procedure or trigger or batch, but when you will select scope underscore identity like this, then you will get the one value, single value. Okay, so therefore this scope underscore identity is more reliable. Mostly as I already explained, and scope underscore ID function is used inside the stored procedures. So that is the answer of this question. What is CTE in SQL Server? Let's first see a simple CTE first, and then we will conclude the definition from that. See the query here. Engineers is the CTE name. Now engineers will contain the data which we get from this select query. Okay. Now this is the CTE body. Okay. Now where to use this engineer city? Okay, we get the data in the engineer city, but where to use? Like this. See, we are using the engineer city as a table or view. So similarly, like we put select query with the tables, we are putting the select query with the CTE also. So sometimes we need this in some scenarios. It's like a bit similar to temporary tables, but it is more beneficial than temporary tables as you do not have to allocate and deallocate memories for CTEs, like you have to deallocate memories, deallocate temporary tables, right? So at the end, the definition is a common table expression is a temporary named result that you can reference within a select, insert, update, or delete statement. In the example here below, we are using CTE engineers with this select query, but similarly, the CTE name can be used with insert, update, or delete queries also. I hope now you get the answer. What is the difference between delete, truncate, and drop commands? This is a very important question, and in many interviews this question has been asked. So I have compared all these three together here. So first we will see their queries. See, delete is used with where condition, whereas truncates and drop do not need where condition. Now you can also use delete without where condition. That time it will delete all the rows of the table. Now see the differences. The first difference is delete is a DML. Okay, just for reminder, insert, update, and delete are DMLs, means data manipulation language. These are used for manipulating the data in your tables. Okay, whereas create, alter, and drop are DDLs, means data definition language. These are used to define the table structure. Okay, so again, delete is a DML, whereas truncate and drop are DDLs. Second thing is delete is used to delete one or all rows from the table based on where condition. So where condition is very important here, but it will never delete schema or structure of the table. Whereas truncate is used to delete all the rows from the tables without where condition, but it will also again not delete the schema or structure. On the other hand, drop command is used to delete all the rows from the table with the structure and schema, meaning drop will remove the whole existence of the table from the database, but delete and truncate will only remove the data. The table structure columns will be there without the data. Now the last difference is delete command can be rolled back, but truncate and dropped cannot be rolled back. Okay, so these are like the three differences between these three commands. Anyone can ask like what is the difference between delete and truncate or drop or delete or drop, but now you are able to answer what is the difference, right? How to get the nth highest salary of an employee? This is a very important question. Interviewer can ask second, third, fourth, any highest salary. Okay. Now there are many ways to do it, and I will try to show you one of them. Suppose we have a list of salary here like this, and suppose we are looking for the third highest salary. So in this case, 6,000 is the third highest salary we need as the output. Okay. First, the logic is first select top three salaries in descending order. This is the query, and this will be the result, which is like top three salaries in descending order, right? Our output 6,000 you can see at the bottom. So now we have to reverse this list. For that, put this result in result, and then do order by salary in ascending order like this. Now see, this is the query and this is the result here. Basically nothing special. We are just reversing the previous result in ascending order now. Now last part is very easy. Just select the top one salary from the result set. See, this is the final query with the top one result, so top one statement. And in the result, you will get the third highest salary. So basically, first you should try to remember the logic step by step, and then you can remember the syntax. And even if you don't remember the syntax, you can explain like, okay, first we will do this, then we will do this, and then we will do this. I think that can also work. So yes, there are other ways to do it, and you can find on Google like for other solutions also. But yes, this is one of the way. What are acid properties? This can be a very big topic, but I will try to answer what you have to tell to the interviewer, what you have to remember. Okay. So first thing is acid properties are used when you are handling multiple transactions in SQL Server. For example, multiple inserts in a table are happening at the same time, same point of time. Okay. Then how you will manage to maintain the data integrity? So first is here A in the acid stands for atomicity, means inside the transactions either all SQL statement execute or none should execute. Okay. So if you have a SP, then inside that SP either all statement should execute or none should execute. This is good, right? Otherwise data integrity problem will be there. Second character of asset is C, and which is C stands for consistency. Means all data inserting or updating should be of valid data type and follow the rules and constraints defined. So whatever data you are trying to enter in your tables should follow the constraints. If it's a not null constraint, of it's a primary key constraint, it's a unique constraint. So your data should follow those rules. Okay, that is consistency. Third character of asset properties is I. I stands for isolation, meaning one transaction should not affect another transaction. So if one user inserting data in one table, then that must not impact other user transaction, like other user also trying to insert some data in that table. So both these two things should happen in an isolated way. Now, because every transaction must be isolated and independent. Last from asset property is D. D stands for durability. What is durability? Meaning inserted or committed data must not be lost, even if there is a power failure. Whatever is committed, right? So these are the important things which you have to follow when you are doing the transactions in your table. So in short, when you are designing your database, then you have to keep these properties in your mind. What are magic tables in SQL Server? The name is magic tables because we do not have to code anything for them. They happen magically in the background. Okay, so see the definition first. Magic tables are the temporary logical tables that are created by the SQL Server whenever there are insertion, deletion, or update operations. Okay, so for example, whenever an insert query runs, then in the background SQL Server create one magic table, and that is called inserted. So that we will discuss. Now there are two types of magic tables which are very simple. Like first is inserted. When any insert query will be executed, then the recently inserted row get added to the inserted magic table. So this inserted magic table is maintained by the SQL Server. Okay. Similarly, another magic table is deleted. When any delete query executed, then the recently deleted row gets added to the deleted magic table. Now you will say, what about the update query? So in update query, the updated row gets stored in the inserted magic table, the new updated row, right? And the old row, like the previous row before updation, will be stored in the delete magic table, right? So there is one row before the updation, which will be in the deleted, and the new row after the updation will be in the inserted magic table. I hope you got it. And at last, the question is when to use magic tables. The use of magic tables are like with the triggers, and this is important from the DBA point of view. But for developers, this much information is enough to know.